back to part 2 of Unit 8.4. Today we're going to be incorporating our knowledge of discriminant to now solve for the roots using the entire quadratic formula. Okay, so using the whole formula, we're going to make sure that our function is first set equal to 0. We're going to do the discriminant first and classify the roots so that we can then check the answer that we get after we've solved the quadratic formula. Okay, so we're going to do the discriminant first. Okay, so A is 1, B is negative 12, and C is negative 28. And we get 256 as our discriminant. 256 is a perfect square. So that means we're going to have two real rational roots. Okay, so that once I solve this whole formula, my roots are going to be two whole numbers. That's what that means. Now, the nice thing about doing the discriminant first, when I then go to solve the quadratic formula, I have already evaluated what's inside the square root there. So I just have to add on those values from the outside. So opposite of my b value is going to be a positive 12. Plus or minus, I'm going to put in that 256 and then times 2a on the bottom. So that's 12 plus or minus square root of 256 over 2. Okay, well 256 is a perfect square. Square root of that is 16. So we're going to evaluate. So 12 plus or minus 16 now over 2. Okay, so that plus or minus I mentioned in part 1, that means we're going to have two options. So we split that up. We have x equals 12 plus 16 over 2, and we have x equals 12 minus 16 over 2. And we evaluate each one of those. So 12 plus 16 is 28, divided by 2 is 14. And 12 minus 16 is negative 4, divided by 2 is negative 2. Those are our roots, 14 and negative 2. So we could solve this by graphing, and that's where it would cross the x-axis. We could solve this by factoring, and those are the roots that we would get. Okay, just make sure that you have x equals written here so that this is in the proper form. Let's try another one. Okay, so I'm looking at my function now, and I see that all of my terms are not on the same side. I cannot solve if it's not set equal to 0. Okay, so I add 121 to the other side. I have everything over there together, and now I'm going to find the discriminant. Okay, again, a equals 1, b equals 22, and now c equals positive 121 because we're working off of this new rearranged function where it's set equal to 0. Okay, so find my b squared minus 4ac Okay, plug that into your calculator exactly as it appears so that you avoid any order of operations issues. Okay, so we get 0. So that means I'm going to have one real rational root. This is only going to cross the x-axis at one point. Okay, so when I solve now, I'm using the entire quadratic formula. Okay, and since I've already done the work for b squared minus 4ac, I can just plug that into the radical. I can just plug 0 in there. Okay, now I'm ready to evaluate. So the square root of 0 is 0. So when I do that, comes negative 22 plus or minus 0 over 2. Well, plus or minus 0 doesn't change any options. So that allows me to just get rid of that. And we're left with negative 22 over 2, which in this case, okay, simplifies out to give us negative 11. Okay, again, make sure you have the x equals written there. But negative 11 is a nice whole number. It's real, it's rational. That is where this function would cross the x-axis. It's only going to cross once, which means that negative 11 is at the vertex. Okay, we saw an example graph in part 1 of 8.4. Okay, one real rational root. This is what the graph would look like. Okay, imagine this is negative 11. That is what the graph of this function would look like. We always compare back to solve by graphing because that's the most visual method that we have. Okay, we're going to move on and do a third example. So we have 4 situations that we actually want to look at for quadratic formula. So we want to make sure that we identify all of them. All right, so everything's on the same side. So I'm going to go ahead and start with my discriminant. All right, so A equals 2, B equals 4, and C equals negative 5. Okay, be careful of those negatives when you're evaluating. Okay, we get 56. So 56 is not a perfect square. Okay, 56 is going to give us 2 real irrational roots. Okay, so if you want to compare this to solve by graphing, 2 real irrational roots is when we had those estimated roots and we identified between what 2 whole numbers it crossed. Okay, so solving our quadratic formula, again, I'm just going to plug my discriminant in since I already did that. Why do the work twice? So we know we get 56. Okay, and then we have 2 times 2. All right, so negative 4 plus or minus. All right, so we have to break down that 56. All right, so there was a little preview video for 8.4 part 2 you need to watch before we solve these next 2 examples because we have to see how to break down this square root. Okay, so we're looking to split this into 2 numbers, one of them being a perfect square, the other one not, that multiply to 56. So the biggest perfect square that I can use here is 4 times 14. Okay, so remember your perfect squares: 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. So those are the first 10. Okay, so I can take the square root of 4. I know what that equals, so I can take that out of the square root. That becomes 2 on the outside, that 14 on the inside. Okay, because I don't know the square root of 14, so I'm leaving it so that I don't have this great big ugly decimal. All right, now very similar to when we simplified, all the way back in like Unit 1, Unit 2. Okay, when we simplify things on the outside, we have to make sure that we simplify all 3 of those. Okay, and if you remember, we do the heart. Okay, so only the things on the outside we make a heart out of. We leave the 14 on the inside alone. Okay, so I can simplify all of this by 2. So this becomes -2 plus or minus 1 square root of 14 over 2. Okay, now you can leave this all together as one big expression. You could also split it up with the plus or minus. Okay, and you don't have to put the 1. I'm just rewriting it so that you understand how we simplified. Okay, so you could leave it here as 1. That would be totally fine for 2 real irrational roots, or this is how it would look split up. Okay, but we leave that square root in there because that is the exact answer. Okay, we just said a couple seconds ago, otherwise we would get this great big ugly decimal. We would have to round it off. It wouldn't be perfect. It would be those 2 estimated roots. Okay, we want an exact answer. So the hard part about problem number 3 here is this step over here with the square root of 56. Okay, we have to make sure we know how to simplify those square roots. Okay, and then reducing, we have to make sure we remember to reduce, number 1. Number 2, use our heart. And number 3, do not reduce inside that square root. All right, we have one more example. Before we can get into it, okay, we have to talk about a concept of breaking down the square root when there's a negative number. Okay, so we cannot have negative numbers under a square root. I think that you learned that, maybe last year. Okay, we talk about that when we do square roots. So there is a special case, however, when you have a -1 underneath the square root. Okay, we can take it out. So like we bring it out, like square root of 4, we bring that out, it equals 2. We can take the square root of -1 and it comes out as an I, and that represents those imaginary numbers where it does not cross the x-axis. Okay, so algebraically, that's how we note that a parabola did not cross the x-axis. We call it imaginary, and we use an I as part of our answer. Okay, so anytime we have a negative underneath the square root, we're going to use this equivalent here. So this is almost like another perfect square to use. Okay, when we're simplifying our square roots, so we can have a -1. Let's take a look at how that works. Okay, so if I have, we'll start with this middle example first. Okay, 64, we know that the square root of 64 is 8. Okay, but we have to take care of that -1. So we split it, -1 and 64. We just split those up because using multiplication, that would still be -64. Okay, so we just said the square root of -1 is an I. Comes out as an I. The square root of 64 is 8. So this would equal 8i. Okay, and we always put the number first because I8 sounds like we're playing bingo. Okay, so we do that easy one where it's a perfect square. Let's look at the first example where it's 32. So we're going to have to break this up into 3 numbers. All right, so first we always take out the negative. So 1 times 32. Okay, but we have to split up 32. So what perfect squares go into 32? Okay, so you take your list of perfect squares. I suggest starting from the bottom so that you hit the biggest one first. Okay, and we're going to use 16 times 2. Okay, so we're looking at square root of -1, square root of 16, square root of 2. So the square root of -1 is the I, square root of 16 is the 4, and then we don't know the square root of 2. So we leave that inside and we put that at the back. Okay, anything we don't know the square root of, we leave that last. And we have one more that we'll do here. The square root of -80. Okay, so it's 1 times 80. That takes care of the negative. And then we'll do 80. Okay, you always want to make sure you're using the biggest perfect square. So we're going to do 16 and 5. Okay, so square root of -1, square root of 16, square root of 5. Okay, so square root of -1 is I, 16 is 4, and since 5 is not a perfect square, we're going to leave that inside. Alright, so this is just how we simplify those negative square roots. So now let's look at our last quadratic formula example. Okay, so get everything to the same side. I'm going to add 13 over there. Figure out my A, B, and C. All right, and start with my discriminant. You get -36. Okay, so that means I'm going to have 2 imaginary roots. Okay, those no real roots. So this graph does not cross the x-axis. So let's see what our roots are going to be. Okay, so opposite of b turns into a +4. We're just going to carry down that -36. Why redo the work? Over 2 times 1. All right, so square root of -36 is -1 and 36 if I split that up. Okay, so the square root of -1 is I, and the square root of 36 is 6. So we're going to take this entire radical here, and we're going to replace it with 6i. Okay, doing some very sophisticated math here with imaginary numbers. All right, so just like we saw in the irrational example, we do have to reduce. Okay, and we can take that 6, even though there's an I, and we can reduce with that. We're going to do the heart. All right, so everything here can get reduced by 2. So this ends up 2 plus or minus 3i. You could write that it's over 1. You don't have to. Okay, you could leave it combined as plus or minus, or split it up. Okay, definitely the first problem that we solved here with 2 rational roots, that absolutely has to be split up because those can be solved. All right, but if it can't be solved, like the imaginary one or the irrational one, you can leave it with the plus or minus, and that's an okay final answer. All right, so those are our 4 situations for solving quadratic formula. Okay, definitely the 2 irrational and the 2 imaginary are your hardest types to simplify and to fully solve. All right, so definitely take a second look at those. Make sure that your notes on those 2 examples are really, really complete. Write down any questions that you have on those so that we can go over them when we talk about this and practice in class together. All right, thanks so much for watching, guys. I will see you in class.